So far, guys, we have already seen the equation of our best fit line in our previous video, which was theta. So far, guys, we have already seen the equation of our best fit line, which was h theta of x equal to theta naught plus theta 1 x1. Now here guys, we have also seen the theta naught is basically known as intercept, theta 1 is basically known as slope, and x is basically known as data points. So we have seen in detail in our previous video that how this equation of best fit line has been derived and which terms basically indicates to what in detail, guys. Now this is simple enough, right? But here comes the big question, guys. How do we actually know if this line is the best fit line or not? And that's where, guys, our cost function comes into the picture. Now, this cost function actually tells us whether our line is best fit line or not. See, here I have already defined the cost function, guys. I have basically note down the equation of our cost function. So focus on this as much as you can, guys. Okay. So here the equation of cost function is basically, guys, see, j of theta naught comma theta 1 equal to 1 by n summation of I equal to 1 to n y of I minus h theta of x of I whole square. Now in this equation, what is y of I? Y of I is basically known as our actual value. Our actual data point is basically denoted by y of I. Then there comes h theta of x of I. Now what is h theta of x of I? H theta of x of I is basically known as, guys, our predicted value, our predicted data points. Now let's see our diagram, guys. See here in this diagram, guys, y of I is basically our y of I, and the equation in which we have stated h theta of x of I. Here we have stated it as y of I, but it's same as h theta of x of I, just notation is different. So this is actually the predicted point. And we have already seen in our previous video what is error. Error is basically y of I minus y of I hat. Means error is basically our original data point minus predicted data points. So what you guys, what will be this y of I minus h theta of x of I? It will be simple, right? It will be error. Why? Because y of I is our actual value and h theta of x of I is our predicted value. So actual value minus predicted value is known as error. Now, what is this error? N is basically known as number of data points, guys. And what is 1 by n? Here we are doing 1 by n means here we are doing average. Here we are taking average of all the error, guys. So this is actually what we call equation of cost function, guys. I have already break this big monster, guys, in front of you. This is actually known as, guys, cost function equation, which is 1 by n summation of I equal to 1 to n y of I minus h theta of x of I whole square. Now there one question arise in your mind, guys. Why actually, we have squared this error. This is error y of I minus h theta of x of I. So why we are actually squared this error? Why we have not taken just a simple difference? Well, guys, see, because positive and negative errors actually cancel out each other. Squaring makes sure that every error count will be a positive value. That's why we squared error, guys, as it's the golden standard. So that's why we have actually squared this error y of I minus h theta of x of I just to get a positive error, guys. So that was actually the reason why we have actually squared the error. And this equation of the cost function is basically known as, guys, mean squared error. Now, why mean squared error? See, first of all, we have, 1 by n means we have done average. So we have find out mean. So that's why we call it as mean. Then we have actually y of I minus h theta of I, h theta of x. What is y of I minus h theta of x of I? It is actually error. And then we have squared those error. We have squared this error. So mean square error. That's why this equation is known as, guys, mean squared error. So equation of cost function is also known as, guys, mean squared error, which is j theta comma theta naught theta j theta naught comma theta 1 equal to 1 by h summation of I equal to 1 to n y of I minus h theta of x of I whole square. Now what is our main aim, guys? See, our main aim is basically to minimize this j of theta naught comma theta 1, because see, our final aim is actually, our final goal is crystal clear, guys. We want to reach to a value where actually theta naught comma theta 1. What is theta naught? Theta naught is basically intercept, guys. And what is theta 1? Theta 1 is basically slope. Now, how it's intercept and how it's slope, this I have already discussed in our previous video. We have already compared it with the equation of straight line. What was equation of straight line? Y is equal to mx plus c. Similarly, equation of base fit line is h theta naught x equal to theta naught plus theta 1 x1. What is theta naught here? Theta naught is basically slope. And what is theta naught is basically intercept guys. And what is theta 1? Theta 1 is basically slope. So similarly here our main aim is that we have to minimize the intercept and the slope here. We have to minimize the theta naught and theta 1 value, and from and here in a broader way, we have to actually minimize the cost function, guys. So the less the value of the cost function will be, that line will be actually our best fit line, guys. So see what I am basically planning, guys. In the next video, we will take one example. We will feed the values in this equation. Literally, I will show you a diagram. I will show you the table. I will draw a table. I will show you a diagram, and what values we will basically get from this cost function, guys. So we will take one example, and we will see how to find basically the value of our cost function, and how to choose the best fit line, and how does optimization process basically takes place. We will see it with the help of gradient descent, guys, and believe me, that would be in depth, guys, because you will get a complete understanding about how the cost function and optimization in linear regression works, guys. Now, why I have not included that in today's video? Reason is very simple, guys, because I want to cover both cost function and optimization in the single video. And in today's video, I have give you the glimpse. I want to give you just an overview of the cost function. So that's why I have decided to keep that entire thing about the example of cost function and the optimization process in the single video. That would be the next video in our machine learning series, so that you get a crystal clear understanding about the optimization process in linear regression, guys. So that was it for today's video, guys. I will see you in the next one.